This is the roadmap to success for acids and bases. So many equations. There are 14 there. What a jungle. So many maths, so many information, so many abstract concepts, all synoptic, so many fundamental misconceptions, and the IB data booklet gives me 2 equations which are the same thing. Where do I begin? The best place to begin is always to begin at the beginning. We started in our SL coursework, didn't we? pH is minus log to the base 10 of the hydrogen ion concentration. Everybody was happy. They hit the log button on the calculator, swapped the sign, normally a minus answer, minus log 10, so it was a positive pH. Everybody was happy. Inverse log 10 to the minus pH, and we can get the H+. And everybody was happy to oscillate between those 2 variables, no problem. We then did pH and pOH. We know that they equal 14. So I have pH or pOH. I can take 14 from it and get the difference, and that will be the one that we are looking for. So there's 3 fundamental differences there. And of course, if pH is minus log to the base 10 of the H+, then pOH is minus log to the base 10 of the OH-. The converse is true. 10 to the minus pOH will give you the OH-. So we're still in the strong area of the strong acids and strong bases, completely dissociated in solution. Be careful that you are using these relationships in a strong acid, strong base situation. What's the relationship between H+ and OH-? Well, that sounds a lot like Kw, doesn't it? The ionic product for water. So H+ times OH- is how much? Yes, 1 by 10 to the minus 14 moles squared decimeters minus 6. That is, thankfully, in the data booklet. So that there is kind of a little quadrant of the equations and application that you would need to be using to be successful in standard level IB chemistry. I say that with no disrespect to standard level. I think there are some very challenging things they can set within there, and of course those can be used in the higher level material as well. And in fact, at the end of a weak acid, weak base calculation, you'll be using those equations for H+ to get the pH or the pOH. So if we have a strong acid, we know that the concentration of H+ is the concentration of the original acid. We can assume that H+ equals HA, so the proton concentration is the same as the acid concentration. Don't forget to double for diprotic like H2SO4 to get the H+. But for a weak acid, Ka is H+ squared over HA, because why? H+ equals OH-. That's just the same as Kc, products over reactants. Look at that, H+ squared over HA. That's where the square root relationship comes through when you are doing calculations. So here we have the HA of a weak acid that we've worked out using the Ka value. And that will give us the Ka, which can either be a pKa, which we unlog, or it can be given in the question, or you can look it up in your data booklet. There are tables of acid dissociation constants in the data booklet. The data booklet will give you pKa. So to get from pKa to Ka, so many Ks, so little time, we need to do 10 to the minus pKa to get the Ka, right? Yes, Mr. Midgley. So how do we go from Ka to pKa? Same as how we go from H+ to pH. It's minus log to the base 10 of the Ka to get the pKa. Oh my gosh. This is why it becomes very easy for students to just scream a little bit into their computer, into their hand, into their elbow, and say, what on earth is going on here? Well, hopefully this roadmap will give you an inkling as to what is going on. As well as the strong, H+ equals HA. For a strong base, OH- equals B. What does that mean? The concentration of OH- is the concentration of the parent base. If it's 0.1 mole per decimeter cubed base, it's 0.1 mole per decimeter cubed OH-. But if it's a weak base, just the same as with a weak acid, Kb equals OH- squared, OH- squared, same rationale as H+ squared, divided by B, the original concentration. So we have a relationship between the original concentration, the OH- concentration, and Kb. Well, there is a relationship between Kb and Ka, as you would expect, but we'll come to that in a moment. So the concentration B of the weak base we get from the Kb. Okay, how do we get the Kb? You could be given the Kb in the question, or we can use the relationship that Ka times Kb is 10 to the minus 14. There it is, that Kw expression rearing its head again. To get from Kb to pKb, minus log to the base 10 of the Kb, or in reverse, 10 to the minus pKb. Just rattles off the tongue, right? And of course, yes, you've guessed it, at the top, I think my pen will just about hit the page, and the relationship between pKa and pKb is pKa plus pKb equals 14. Now hopefully the strong at the bottom and the weak, well, the strong in the bottom third and the weak in the top 1/3 is helping you to see how we could potentially begin to navigate a given question in the IB. And let's not forget that we can also look at the titration curves, where pH is pKa at the halfway point and pOH is pKb at the halfway point, so the half of the equivalence point. So we can get right from the top of this roadmap, from pKb back to pOH, and from pKa to pH using graphical experimental methods, because pH is pKa at the half equivalence point. As an aside, that also makes an excellent internal assessment because the data processing is fabulous. Now, practice, have a look at some of my videos on calculations for weak acid, weak bases. And yes, the jungle has very little, just one equation really. So you need to learn the other 13 or know how to derive them and why they are as they are. Time to start practicing. Get out the jungle by comment, liking and subscribing.